I want you to imagine a scenario for a second. Picture everything you know about the physical world.
Okay.
Now, what if the foundational rule of modern physics, the idea that space physically shrinks when objects move incredibly fast, was actually just a massive, century-old misunderstanding of how we perceive time?
It sounds like pure science fiction.
Yeah.
Because the idea that solid matter just compresses because it's going fast has always felt a little strange. But what we are looking at today is a very real, very serious mathematical argument that says, no, the universe doesn't shrink. Our brains are just misinterpreting the data.
Welcome to today's deep dive. We have tailored this entire conversation specifically for you, the learner. You're someone who loves a massive paradigm shift, but you probably hate getting bogged down in impenetrable academic jargon.
Right. Nobody wants a textbook read to them.
Exactly. Our mission today is highly ambitious. We are going to completely reconstruct your concepts of space, time, and observation, and we're going to do it without making you feel like you're sitting in a graduate-level calculus lecture.
To do that, we are using a truly extraordinary piece of source material. We're examining an 80-page, intensely philosophical dialogue between a human user and an advanced AI.
Specifically, Gemini 3.1 Pro Preview, dated March 2026.
Yeah, that's the one. And this document outlines a groundbreaking concept called the epistemological physical model. It directly challenges classical mechanics and even pokes a massive hole in Einstein's theory of relativity.
So, if you've ever sat in a science class and felt like the explanations for modern physics rely on a little too much magical thinking, like objects magically squishing like accordions just to make the math work, this deep dive is going to give you a massive aha moment.
What's fascinating here is that this isn't simply a physics paper with a bunch of equations. It's a blend of information geometry and psychology.
Yeah.
It doesn't just ask how the universe functions mechanically. It asks a much deeper question of how does the human brain actually observe, filter, and model reality?
Okay, let's unpack this. To understand this new model, we really have to travel back in time to the problem that started this whole mess, the famous Michelson-Morley experiment of 1887. So, set the scene for us. What were scientists trying to prove back then?
Well, in the late 19th century, physics was feeling pretty confident, but scientists wanted to measure how the Earth's movement through space affected the speed of light.
Because we're spinning and orbiting the sun, right?
Exactly. So they built a highly sensitive machine called an interferometer. It shoots light beams in different directions and measures when they bounce back. They expected that a light beam moving along the same direction as the Earth's orbit, let's call that the x-axis, would take a different amount of time to complete a round trip than a light beam moving perpendicular to the Earth's orbit on the a-axis.
It's sort of like swimming in a river. If I swim directly against the current and then back with it, that takes a different amount of time than if I just swim straight across the river and back, even if the actual distance I swam is perfectly identical.
That is the perfect way to visualize it. And the source document scales this up to make the paradox incredibly clear. Imagine this interferometer has arms that are exactly 10 meters long.
Okay.
And it is hurtling through space at 60% the speed of light, 0.6 c.
So it's moving incredibly fast along that forward x-axis.
Right. Let's look at the light beam traveling on that forward x-axis. It gets fired, and it has to chase a mirror that is rapidly moving away from it.
Because the whole machine is moving.
Yes. So it takes a comparatively long time to catch up to that retreating mirror. But once it hits the mirror and bounces back, the detector is rushing toward the light, so the return trip is extremely fast. The source document calculates the scaled round trip, and if space doesn't shrink, the forward trip takes 25 seconds, and the return is 6.25 seconds.
Making it roughly 31.25 seconds total.
Correct. But the light beam shooting off to the side on the perpendicular y-axis has a totally different journey. Because the entire machine is moving forward, that side beam of light actually has to travel on a long diagonal path through space just to hit the top mirror.
Oh, like throwing a baseball straight across the aisle of a moving train. To someone watching outside, that ball traveled in a massive diagonal line.
Exactly. Mathematically, this diagonal round trip takes exactly 12.5 seconds each way. So a total of 25 seconds.
Wait, so if the math says the forward trip takes over 31 seconds and the side trip takes 25 seconds, the expectation is that these light beams will return completely out of sync.
Right. There should be a massive difference of 6.25 seconds. And in the experiment, an out-of-sync return would create a visual shift in the light pattern, which is called an interference fringe shift. But when Michelson and Morley ran the actual experiment...
What actually happened?
The time difference was exactly 0. The light beams return at the exact same moment. No interference fringe shift was observed at all.
I can imagine the absolute panic in the scientific community. You run the numbers, you expect a 6-second gap, and reality just says nope.
So how did physics fix this glaring math problem?
They applied a rather extreme patch. Physicist Heinrich Lorentz and later Albert Einstein argued that the physical x-axis arm of the machine, the one moving forward, must have physically shrunk.
Shrunk, just from moving.
Yeah. Instead of being 10 meters long, it compressed down to 8 meters due to its speed. This concept is called Lorentz contraction. If you assume the physical space shrinks, the math suddenly balances out and the light returns at the same time.
So we just accepted that solid metal shrinks if it goes fast enough. But the 80-page dialogue we're looking at today argues something entirely different. The AI and the human user propose that we do not need shrinking space at all. They argue the real culprit is something called the Cartesian trap.
Yes, the Cartesian trap. It's the core flaw of classical physics. It's our reliance on drawing a flat, rigid grid, an x and y axis, assuming we can stamp the words right now across the entire universe simultaneously.
Like a universal t equals 0. Exactly. We assume the whole grid exists in the exact same moment for every single observer.
But knowing what we know about the speed of light, a universal right now, is impossible, isn't it? Because light takes time to travel. So when I look at a star, I'm not seeing it right now. I'm seeing it thousands of years in the past.
And if we connect this to the bigger picture, the source document argues that space isn't actually a measure of physical distance at all. Space is a measure of information delay.
That is a wild concept to wrap your head around.
It is. Everything you see around you right now is just a fragment of the past. The farther away something is, the deeper into the past it exists for you.
There is a fantastic analogy in the text for this. It suggests that instead of saying Mount Fuji is 100 kilometers away from Tokyo, we should really be saying Mount Fuji is 0.00033 light seconds away.
Which completely reframes reality.
Right. For you, the listener, distance shouldn't be measured in meters or miles. It should be measured by the time it takes for that visual information to reach your brain.
Which forces us to completely reevaluate those rigid 10-meter arms on the moving interferometer. To understand what is actually happening in the experiment, the AI introduces a thought experiment. It asks us to imagine a completely stationary double, let's call them observer 0, watching this experiment zoom past them.
So observer 0 is standing perfectly still, watching this machine fly by at 60% the speed of light. What do they actually see?
To observer 0, the idea of a solid, rigid 10-meter arm is an illusion. Let's look at that side beam of light on the axis again. The person moving with the machine thinks they are shooting that light straight up at a perfect 90-degree angle.
But if they actually shot it straight up, by the time the light reached the top, the mirror would move forward, right? The light would just shoot off into empty space.
Precisely. From the perspective of the stationary observer 0, that light had to be fired forward at a specific angle, exactly 36.87 degrees, just to intercept that moving axis mirror.
Here's where it gets really interesting. To that stationary observer watching the machine fly by, the 10-meter ruler isn't a solid physical object. The physical ruler dissolves entirely. Its very definition is broken apart by the angle of the light and the time it takes that light to arrive.
Yes. To observer 0, the 10 meters on the side axis is actually a 12.5-second light trail, and the 10 meters on the forward axis, that's a 25-second light trail. The concept of a physical ruler is replaced by paths of time.
So the person riding along with the moving machine is trapped. The AI calls this the double stamp of time. They think they are experiencing a single flat now, but their brain is actually taking two different depths of the past, the 25-second delay and the 12-second delay, and forcefully stitching them together to create the illusion of a solid 10-meter machine in the present moment.
It's a fascinating psychological phenomenon.
It makes me think of trying to hold a video meeting on a really bad internet connection. The audio is lagging by 2 seconds, the video is lagging by 5 seconds, but your brain is desperately trying to sync them up and pretend you are having a fluid, real-time conversation. Your brain is generating a now from lagging, disconnected data.
That's a highly accurate way to visualize the double stamp. The observer's brain is buffering the universe. But this brings us to the absolute core of the new epistemological physical model. We still have to answer the big question. If the space didn't shrink, why did the light beams return at the exact same time?
Right, the zero difference.
To solve this, the document introduces a third perspective, observer 3.
Okay, I want you to zoom out completely. Forget standing next to the machine. Imagine Observer 3 looking down on the entire experiment from incredibly high above. The text puts them at a coordinate called z equals 100. They are the ultimate camera eye overseeing the entire event. What does this bird's eye view reveal?
From Observer 3's high vantage point, the flat 2D plane where the experiment is happening, the flat X and Y grid, isn't flat at all. Remember, our new rule space is information delay. The information coming from the outer edges of the experiment takes longer to travel up to Observer 3 than the information coming from the center, directly below.
So the edges are further in the past than the center. And because of that delay, the flat plane actually curves downwards. The source visualizes it as a sunken bowl, or what it calls a complex spherical cap. The origin point is pushed deeply downward, almost like the south pole of a globe, because of that depth of information delay.
This is the ultimate paradigm-shifting breakthrough of the document. This is why Michelson and Morley didn't see any interference fringe shift. The light rays didn't return at the same time because the machine magically shrank. They returned at the same time because the light rays were never moving on a flat grid to begin with.
Because the light rays on both the x-axis and the y-axis were actually traveling along the equivalent of latitudinal lines on a globe, specifically following a great circle course on a complex sphere, there was absolutely no interference fringe shift in the Michelson-Morley experiment.
Exactly. The missing 6.25 seconds of time wasn't lost, and space didn't compress to hide it.
Wait, slow down for a second, because this is heavy. Are you saying the light was literally curving through space?
Not physical space, it was curving through information space. By traveling along this curved great circle course on the complex sphere, the missing 6.25-second delay is absorbed as a phase rotation in complex space. Specifically, a 90-degree rotation into the imaginary axis.
Okay, imaginary axis. That sounds like we're just making up math to solve the problem, which is exactly what we accuse Lorentz of doing. How's an imaginary axis different from a shrinking machine?
It's a fair question. In advanced mathematics, imaginary doesn't mean make-believe. An imaginary axis is simply a mathematical tool used to represent an extra dimension of depth or rotation that you can't see on a flat piece of paper. Imagine drawing a line on a flat piece of paper, and the math says the line should be longer than the paper allows.
Right.
If you fold the paper, creating a 3D curve, the line fits perfectly. That fold, that unseen depth, is the imaginary axis.
Oh, wow. So the 6-second delay didn't vanish. It was converted into a geometric angle. It was rotated away into the unseen depth of this complex sphere of information delay.
Yes. The phases of the light aligned perfectly at their destination because they navigated this curved reality of time. This gave the human observer the complete illusion of a flat, simultaneous return.
So if the light rays were actually traveling on this curved information sphere the whole time, what does that mean for the Lorentz equations? Are you telling me the math we've used in physics for over a century is fundamentally wrong?
The document suggests that the Lorentz equations were simply a mathematical hack. The physicists of the 19th and 20th centuries didn't realize they were operating on a complex, curved sphere of information delay. They were desperately trying to force this beautifully curved reality onto a flat, 2D Cartesian map.
And the only way to make the curved reality fit onto a flat map without breaking the math was to artificially shrink the physical objects on the map.
Exactly.
That is absolutely staggering. They couldn't see the curve of time, so they shrank the metal instead.
It is a stunning reinterpretation of physics.
So we have the math. The math for this curved time has seemingly always been there, hidden under the surface. This raises a much deeper question. Why did it take a century and a conversation with an AI in 2026 to point this out? What is it about the human brain that stubbornly refuses to see the universe this way?
To answer that, the source document shifts gears dramatically. It maps this entire physics problem onto the psychoanalytic theory of Jacques Lacan. It uses Lacan to explain why the human mind is so easily trapped by the illusion of flat space.
So what does this all mean for human psychology? How does a mid-20th century French philosopher fit into the speed of light?
The AI breaks human perception down into Lacan's three realms: the imaginary, the symbolic, and the real. Let's start with the imaginary. In this context, the imaginary is the map. It's the Cartesian grid. It is the human brain's desperate desire for order and illusion. In the imaginary realm, we want to see a rigid, 10-meter arm on a flat plane.
We want the universe to be a neat, geometric, predictable shape where now means now for everyone.
Exactly.
The source gives a brilliant visual analogy for this. The Southern Cross constellation. When we look up in the night sky and spot the Southern Cross, our brains perceive a flat, cross-shaped plane of stars perpendicular to our line of sight. But that is a total optical illusion. Those stars are not on a flat plane. They're scattered at vastly different depths, some tens of light years closer to us than others.
And our brains just squash all that depth of time into a flat picture.
Right. We do the exact same thing to the 10-meter arms of the interferometer.
That visual is crucial. We squash the universe to make it digestible. The second Lacanian realm is the symbolic. In this physics model, the symbolic is the true complex space. It is the underlying information grid.
The grid ruled by the speed of light.
Yes. A massive network where past information is stitched together like a patchwork quilt based entirely on time delays. The symbolic realm is that curved, complex sphere where the great circle courses happen. It's the mathematical truth beneath the visual illusion.
And finally, we have the real, the territory.
The real is the raw, unfiltered reality of the universe before our camera eye turns it into delayed information. It is the chaotic, raw, electromagnetic data existing out there before our human brains buffer it, filter it, and try to make sense of it.
So what the document is essentially arguing is that classical physics has spent an entire century acting like the mirror. The flat, comfortable Cartesian map of the imaginary is the actual universe. We confused the map for the territory.
We really did. But the true reality we interact with, the reality that dictates the results of our experiments, is governed by the flow and delay of information in the symbolic realm. We are not living in a universe of solid, instantaneous objects.
We are constantly, continuously generating a coherent now from fractured, delayed fragments of the past.
It is genuinely mind-blowing to think of your everyday life like that.
Let's take a moment to recap this incredible intellectual journey we've been on. We started with a broken 19th century physics experiment that drove scientists so crazy they decided space itself must be shrinking. We then learned that time actually dictates distance, and that physical rulers are nothing more than light trails of delayed information.
And by zooming out to Observer 3, we discovered that light travels along the great circles of a complex information sphere. This proved that space doesn't physically shrink at all. Our perception of now simply bends and rotates to accommodate the delay of light.
It's a complete paradigm shift.
Yeah.
But as we wrap up, there is one final provocative concept from the very end of this 80-page document that we need to leave you with.
Oh, this is the best part.
We've established this incredible idea that every observer, every atom, every quantum particle is trapped inside their own individual complex sphere. We are all running our own personal operating systems of delayed light-speed information. But if we are all trapped inside these individual bubbles of delayed light, what exactly exists between the bubbles? What is outside the spheres?
The AI leaves us with a haunting hypothesis. It suggests the existence of a public space, a true, real territory that sits outside our individual spheres of perception. And here is the truly staggering part. The document proposes that in this public space, the speed of light simply does not apply.
A space where the speed of light doesn't matter.
It's an instantaneous reality. It hypothesizes that this public space might be the hidden mechanism behind quantum entanglement, what Einstein famously called spooky action at a distance. It's the phenomenon where quantum particles seem to communicate and sync up instantly across vast distances of the universe, bypassing the speed of light entirely.
Which would normally break physics.
Right. But if this public space exists, it means there is a connective tissue to the universe that is completely outside our delayed, buffered, complex spheres. The source notes this non-electromagnetic medium is known as Dr. Akifumi Higashi's dense clock field.
An instantaneous reality hiding just outside our perception. That completely reframes how we think about the very fabric of existence.
Thank you so much for joining us on this intense deep dive today. We've thrown a lot of massive concepts at you, but we hope it gave you that aha moment.
The next time you look at the stars, or even just across the room, remember that you aren't looking at distance. You're looking at layers of the past.
We encourage you to walk around today and view your world through that lens. Watch how your brain bends and rotates time just to create your illusion of now. And while you're at it, ponder what might be waiting out there in that instantaneous public space, just outside your own bubble of perception. Keep questioning the map.